Okay, next we're going to talk about solving proportions. And a proportion is essentially two fractions that are equal to each other, or two ratios that are equal to each other. So in order to solve a proportion, we cross multiply. What do I mean by cross multiply? I multiply this denominator times that numerator, and this denominator times that numerator. So I get 21 times y minus 2 is equal to 27 times y. Distributing that 21, I get 21y minus 42 is equal to 27y. If I subtract 21y from both sides, I get negative 42 is equal to 6y. You divide by 6, and you get negative 7 is equal to y. Now I need to make sure that that won't create a 0 in the denominator, which it won't, so my solution is valid. Let's try one more. I have w plus 1 over w is equal to 40 over 35. Now 40 and 35, I could reduce this, and then I would be dealing with smaller numbers. So I'm going to go ahead and do that. They both divide by 5, and that gives me 8/7. And then I can cross multiply, and I get 7 times w plus 1 is equal to 8w. So 7w plus 7 is equal to 8w. Subtract 7w from each side, and I get 7 is equal to w. Now, if I hadn't noticed this, and I cross multiplied without reducing, I would get 35 is equal to 5w, and dividing by 5, I would still get w equals 7. So even if you don't reduce it, you're going to end up with the same answer. It's just the reducing, well, quite honestly, made the math easier. Okay. Now, here we have word problems involving proportions. There are two ways to do this. We can set up a proportion and we can solve this problem algebraically, or we can solve it without using any algebra at all. So let's talk about the proportion. When you're setting up a proportion, we have gallons and miles. So I have to keep my units the same. So if I do gallons over miles, I have to do gallons over miles, or miles over gallons, miles over gallons. If Addie drove 15 miles on 303 miles on 15 gallons of gas, that's one set. And we want to know how many miles if she used 19 gallons of gas. So I know 15 gallons gave her 303 miles. 19 gallons is going to give her an unknown amount of miles. I'm then going to cross multiply, and that gives me 15x is equal to 57. And if I divide both sides by 15, I am going to get, okay, 383.8. So x would be 383.8. Now, there's another way to do this. I can divide to find my miles per gallon. And to do that, I take my miles and I divide by my number of gallons. So I'm just going to cheat a little here. And if I do 303 miles and I divide that by 15 gallons, I get 20.2 miles per gallon. And now I want to know how far I could go with 19 gallons. So this is going to be multiplication. So I'm going to multiply 20.2 times 19, and I get 383.8 miles. So as you can see, this is two ways to work the same problem. Let's try another one. Keisha, let's say Keisha, no, like Kesha. Keisha drove 204 miles using 8 gallons of gas. So I'm going to do 8 gallons over 204 miles is equal to 14 gallons over some unknown amount of miles. So I get 8x is equal to 14 times 204, which gives me 2856. Divide both sides by 8. And you get 357, right? Yeah, 357 miles. Or, if I don't want to use algebra, I can go back to old-fashioned arithmetic, and I can say that 204 miles on 8 gallons is 25.5 miles per gallon. And then I take that 14 gallons of gas and I multiply that by 25.5 miles per gallon. I'm going to go 357 miles. Okay. Here we have another type of proportion. Residents of a city voted on whether or not to raise property taxes. We have a ratio of yes to no. So we have yes, no. There are 6,874 yeses. We want to know, though, what is the total number? This is going to tell us the number of no's. X is going to tell us the number of no's. The total number is all of the yeses plus all of the no's. So we need to find out how many no's were there. So we're going to solve this proportion for X, the number of no's. Then we need to add that to the number of yeses to find the total number. So I get 7X is equal to 6,874 times 4, so that's 27,496. Divide both sides by 7, and I get X is equal to 3,928. So there were 3,928 no votes. So I'm going to add that to my 6,874. So my total number of votes was 10,802 total votes. Okay, so this is a two-part problem. We have to set up a proportion and solve it, and then we have to add that in order to get the total. So let's try one more like this. We have a ratio of men to women working for a company is 6 men to 5 women. Okay. Actually, this one's a little different. We have 6 men to 5 women. We have 198 employees total. Okay. For every 6 men and 5 women, that's 11 employees. have 198 total employees, and I'm going to divide that by 11 because there are going to be groups of 11 employees each with 6 men and 5 women. So 198 divided by 11 is 18. So there are going to be 18 groups of 6 men and 5 women. Well, I don't want to know how many women work for the company. I only want to know how many men work for the company. So I'm going to do 18 times 6. And that's 108 men working for this company. Now, just to double check myself, if I do 18 times 5, and I add those together, I will get the total back. It's a nice way to double check yourself. Okay, here we have multiple rates. Okay, this is where you have 2 machines, 2 pumps, 2 hoses working together in tandem. We have machines that produce cans. The new machine produces 6,600 cans in 220 minutes. That is a rate of 30 cans per minute. Okay, the old machine does the same number of cans in 330 minutes. That is a rate of 20 cans per minute. We want to know if they're working together, how long will it take them to make that same number of cans? This is their individual rate. Together, they're going to do 50 cans per minute. So I'm going to take that 6,600, I'm going to divide it by 50, and I'm going to get 132 minutes. So working together, they'll only take 132 minutes. Let's try another one of these. We have 480 dishes that need to be rinsed. John can rinse them in 120 minutes by himself. It takes Bob 80 minutes to rinse these dishes. So let's do John. He can do 480 dishes in 120 minutes. That's 4 dishes per minute. So DPM, dishes per minute. Bob can do the same number of dishes in 80 minutes, so he can do 6 dishes per minute. Together, they can do 10 dishes per minute. So if we do the same number of dishes, 480, and we divide it by 10 dishes per minute, it will take them 48 minutes to rinse all of the dishes. Okay, for our next problem, we're going to solve a word problem using a rational equation. Okay, so we have one hose can fill a swimming pool in 75 minutes. So we're going to do hose 1, that's 75 minutes. And hose 2 can fill the pool in 50 minutes. Now, there is one pool. Okay? So hose 1 is going to be 1 over 75. Hose 2 is going to be 1 over 50. This is one pool, 75 minutes, 50 minutes. Working together, how long will it take? We still have one pool and X number of minutes. Now to clear these fractions, I can multiply by the common denominator, The common denominator between 75 and 50 is 150. Sorry, that's not how we want to go. We're not clearing the fraction, we're just looking for our common denominator. So let me try that again. Sorry about that. We have 1 over 75 plus 1 over 50 is equal to 1 over x. Our common denominator is going to be 150, so I need to multiply this one by 2 over 2 and this one by 3 over 3. So I get 2 150 plus 3 over 150 is equal to 1 over x. That gives me 5 over 150 is equal to 1 over x. I can divide both of these by 5. So I get 1 over 30 is equal to 1 over x. X, therefore, is equal to 30 minutes. Now, whatever we get here on this type of problem where we've got two people working together to do a job, this time should be less than either of the two times you started with because you've got two hoses. If one hose does it in 50 minutes and that's the shortest amount of time, two hoses are going to do it shorter time than this no matter what. So let's try another one of these. Okay. We have hose 1 and hose 2 again, and then we have together. Okay, working together, they take 35 minutes. If we have one hose that takes 60 minutes, we want to find out how long is it going to take the small hose. So there's one pool, 60 minutes, one pool, unknown number of minutes, and if I work together, it takes 35 minutes. So I'm going to subtract 1 over 60 from both sides. So I get 1 over x is equal to 1 over 35 minus 1 over 60. Now I need to find my common denominator between 35 and 60. A nice way to do that, to find common denominators when you can't think of one off the top of your head, is to use a factor tree. Okay. 35 is 5 times 7 and 60 is 5 times 12. I can take this 5 out. So my common denominator is going to be 5 times 7 times 12, which is 480. Because 5 times 12, not 480, 420. 5 times 12 is 60, times 7 is going to give me 420. Okay, 35 is already 5 times 7, so I only need to multiply it by 12 to get 420. And 60 is 5 times 12, so I only need to multiply by 7 to get 420. So that gives me 1 over x is equal to 5 over 420, both of which will reduce by 5. So that will give me 84. So x is equal to 84 minutes. And that is using proportions to solve various problem types.